Okay, so actual play is related to soccer. All right, so soccer player is kicking the ball at 70 miles per hour, right? At an angle of 20 degrees. 20 degrees with respect to the horizontal, so which means that it's being kicked with respect to the horizontal. So that's the motion part. Okay, so how much far does the ball travel along the horizontal direction? How far? Okay, how much far? How far does the ball travel along the horizontal direction? All right, so the final result needs to be expressed in units that makes sense to us in the United States, which means that we have to convert it to feet at the end. All right, so I'm just going to draw this out. The ball is being kicked at an angle, so it's going to be projectile motion. All right, so this is V. Okay, so what do we know? We know this speed. Excuse me, it's going to be 70 miles per hour, so it's being kicked at an angle of 20 degrees. And we want to know how far it's going to travel along the x direction. Okay, that's it. Okay, so this thing is extra credit because this requires a little bit of work. All right, so having said that, all right, the first thing you need to do is the conversion, 70 miles per hour to meters per second. So just give me that if you have the conversion. All right, and 31.25. Those of you guys who, Rosanna and Eric, give yourselves 5 points. 31.25 meters per second. Okay, good. All right, this is full projectile motion. Okay, so what I'm going to do, I'm going to put down the formulas on the side. Formulas on the side. Okay, and then we can pick and choose. Full projectile motion. Along the x direction, this is what the motion looks like. Nothing's going to change. Along the y direction, you got the free fall equations, plus or minus. All right, so let me back out of there. All right, so this is going to be 1/2 GT squared. Final speed, initial speed, plus or minus GT. Final speed squared, initial speed squared, plus or minus 2GY. Okay, so, all right, so these are the full projectile motion equations. Another thing that we know is there's a little bit of geometry involved. It's not geometry, it's trig in this case. All right, so initial velocity is going to have 2 components. It's going to have an x component. Also it's going to have a y component. Expressing it in terms of the angle. X component and the y component. The y component is going to be the sine of the angle. And x component is going to be the cosine of the angle of the vector itself. Okay, so that's what we got. Okay, so what is it that we're looking for? We're looking for x. Okay, so it's crucial that you list everything. And then in the United States, we express this in terms of feet. Okay, now I know what I'm looking for. I'm looking for this. So now that I know I'm looking for this, boom, here's the formula. Okay, so once again, I'm going to attack the solution directly. This is what I need. All right, so x is initial speed along the x direction times time. All right, so I don't know what time is. I'll worry about it later, but I know what this is. Okay, so I know the initial velocity. I know the initial speed, so the x component of the initial speed is right there. All right, so I know what this is, so I'm just going to go, oh, okay, so x component of initial speed is going to be the initial speed times the cosine of the initial angle. All right, so back substitution. Okay, so I'm good right now. Okay, so what do I know? I know the initial speed, which is this. Okay, so I need to make an adjustment. Initial speed. I know the angle, so we're good. So the only thing we're missing is t, right? Where do we get the t from? Okay, so here's the reason why drawing is important, guys. The amount of time it takes for it to go up and down on the y direction. So the amount of time for it to rise up to the peak point and then come back down is the same time it's going to take for it to travel this distance. All right, so the time it takes for it to go up and down is the same time it's going to take for it to travel in this direction. So what that means is this time that we're looking for the time it takes for it to travel this distance is the same time it's for it to travel up and down. Okay, so which means that we got two formulas available to us, this formula and that formula, in order to solve this for t. Okay, so the question is, which one are we going to use? Okay, so it's a trial and error. Can I use this? The answer to that question is no, because I don't know what the final speed is on the y direction. Okay, and for me to be able to do that, I need to get the final speed from here. That's just way too much work. So you need to get the final speed from here, substitute it here, and that's out for t. Forget it. That's too much work. This one is promising because I know the final height. What is the final height right here? It's going to be 0. All right, so I know the final height. So final height is going to be 0. And I can figure out the component of the initial speed on the y direction. I know what g is. So this one is promising. So that's the one I'm going to use. All right, so here's what I got. Initial velocity on the y direction times time plus or minus 1/2 gt squared. So what do I know? I know that the final height is going to be 0. Also know that initially this thing is going up against gravity. All right, so y component of this is pointing in the opposite direction of gravity. So gravity is going to have a negative effect on this one. So what I'm going to do is I'm going to use the negative sign, which means that gravity is going to slow this thing down. All right, so I'm just going to rewrite this formula. It's going to be 1/2 gt squared. And I'm going to move this across. Or, oh, I killed, all right, I killed the X. Okay, let's do this again. I killed the connection by accident. Okay, so let's do this again. Okay, so it's going to connect. Okay, so let's go back. Okay, so let me move this across. In the name of showing work, I'm showing way too much work, which is good for you guys. Okay, so, all right, so you got t squared, you got t, these two will cancel. I'm going to rewrite this, so t is on the left-hand side. Multiply both sides by 2, divide both sides by g. All right, so because I'm showing way too much work, I'm going to spill into this region. I'm going to continue there. All right, so t in this case is going to be 2 times the initial velocity along the y direction, divided by g. Initial velocity along the y direction can be expressed in terms of the initial velocity and the angle of the initial velocity. All right, so here's the initial angle, here's the initial angle. So this thing here is going to be expressed in terms of the sine of the angle. So we do a back substitution. Okay, so that's what we end up getting. Okay, so this expression is going to go right there. Okay, I just want to get my alignments right. All right, so which means that the x is going to be 2 times VO times VL. It's going to be VO squared. It's going to be the sine of the angle theta, sine of the angle theta, cosine of the angle theta. Everything is going to be divided by g. Okay, so at this point, I'll check to see if I got everything that I need. I got the initial speed, boom, 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 it's right there. I got the angle, it's the same angle. I got a value for g. All right, so g, once again, is roughly about 10. That's it. I can clean this up if I wanted to. Okay, Khan, this is this is extra credit. This is similar to a problem that we've done in class, except it's an easier version of it. Okay. If you can't do this sort of stuff, it's not a big deal. It's no harm. All right. This is for those people who are really, really motivated. Believe it or not, there are students who can do this sort of stuff. Okay. So that's it. You can plug your numbers in, and this is the final equation. I was going to simplify it a little bit more.